Hello, welcome back. So in this part, we are going to discuss a very important concept which is related to the moment, and that is moment of a couple. Well, the concept I have introduced in the start of this lecture that was actually related to the couple. So basically, a couple, it can be defined as two parallel forces, actually unlike parallel forces that have the same magnitude but opposite in direction, and they are separated by a perpendicular distance d as shown in the figure. So I will be showing you the figure. So you can see I have taken the similar example in the start of the lecture to understand the concept of moment. So this is actually the set of couple. So in the set of couple, there are two unlike parallel forces. Well, unlike parallel forces are which are parallel, but their sense is different. So these are the like parallel forces, but this is unlike parallel forces. So couple will occur only when there are two unlike forces and they will be of same magnitude. So I have provided negative F because it is on the leftward side. So as per sign convention, we take leftward force as negative. Similarly, this is rightward. So I have taken this as F positive. And when they are separated by a distance D, then the system is known as the couple. Okay. Now, in this case, you can see the resultant of the force is 0. If we calculate summation of H, so this will be minus F plus F. So this will be 0, which means the system should be in equilibrium, but it is not in equilibrium. Why? Because there is a distance between these two forces, and because of this distance, there will be a movement in terms of the rotation. So this application of couple is used in many areas. I will take an example for that. So basically, the magnitude of the couple can be calculated as magnitude of the force multiplied by the perpendicular distance. So there you can see. So magnitude of any one force multiplied by the arm, the distance between those two forces. So this is how we can find out the magnitude of the couple. And couple can be clockwise and anti-clockwise. So this is again I mean couple is actually moment, but the system that we are referring, it is actually known as couple. Now the application of couple found in many areas, and one of the area I would take example of the steering that we use in the vehicle. So we use steering uh, in the vehicle to turn the vehicle. So for example, this is the steering, and when we hold the steering, so our one hand is on this side and the other hand is on this side. So when we are supposed to turn the vehicle, so what we do is we uh, apply, if we want to turn on this side, then what we will do is we will turn this steering like this. So in that case, what is happening? One force is coming in this direction and the second force on the other end is coming in this direction. So that is why the vehicle will turn in this direction. Similarly, if you want to turn in this direction, then it will become upward and this will become downward. So that is the application found in the steering. Well, there is another concept which is related to couple, which is called the equivalent couple. Now, what is the meaning of equivalent couple? It says if two couples produce a moment with the same magnitude and direction, then these two couples are equivalent. We will understand this with this example. There you can see there is a steering wheel, and in this the force is applied. So in this 30 Newton force is applied on both sides, and the distance between the force is zero 0.4 meter. Now the couple created because of this system, it will be 30 into 4, so it will be 12 Newton meter. Okay. So this will be around 12 Newton meter. Now, if this is similar to the second system, in this system, what we have done is we have shortened the circle, and now we are applying more force, and also the distance is decreased. Now, in this case also, the couple magnitude will be 12 Newton meter. So in that case, the couple generated because of these two systems will be known as equivalent couple, which means the magnitude of force and the distance is different, but their magnitude is, if the magnitude is same and direction is also same, in that case we will call both the system as equivalent couple. Now this is actually the example of steering wheel. Well, earlier in the vehicle, until the invention of the power steering, we used to have larger dia of the steering, and because of that we used to apply more force to turn the vehicle. But after the invention of the power steering, after the use of power steering in the cars, so now we have small dia of the steering, and because of the power steering, power transmission, we can apply less force, and at the same time we will be having the same couple. We will be applying the same torque to generate or to rotate the vehicle. So that becomes possible after the invention of the power steering. So that is the classic example of this equivalent couple system. Now we will take an example to understand the couple. So in this, we have to find out the magnitude and direction of the couple acting on a gear. You can see this is the figure, and this figure is actually the figure of gear, the gear that we use in the vehicle for power transmission. So in this, you can see there are two forces. One is 600 Newton. The direction is, I mean, the sense is towards this direction. Similarly, there is another force which is of the same magnitude, and also the direction. You can see here the direction, the same force is making 30 degree from the horizontal. It is making this angle. Similarly, the same force on the opposite direction, it is also making the 30-degree angle from the horizontal. So now in this case, what we have to do is we have to find out the couple. Why? Because you can see if we extend the line of action of this force, so you can see there is a distance between these two forces. So these two forces are equal and opposite in direction, and because there is an arm which is being present between these two forces, so rotation of the gear will be happening. So we have to find out what will be the magnitude of the couple in this case. Now you can see finding the distance d will be a little difficult. In this case, it would be difficult what will be the value of d. So in that case, what we can do is we can apply the Varignon's theorem, and according to Varignon's theorem, the magnitude of the moment in this case will be equals to the algebraic sum of the magnitude of the components of these forces, moment of the component of these forces. So you can see in the second diagram I will show. So you can see this force F 600 Newton, it can be divided into two components. It can be converted into two components. So this force will be having two components. One is horizontal component and second one is the vertical component. So now because of the creation of these two components, we will be having two couples. One couple because of this vertical forces, and the second couple is because of this horizontal force. So magnitude of the algebraic sum of these two couple will be equals to the magnitude of the couple because of this single force. So that is why what we will be doing is we will be calculating the resultant moment in that case. So sorry. So we will be calculating moment about O. So we will calculate moment about O. In this case will be 600. First we will take this force. So you can see this force is having a distance which is 0.2 meter. So we will write 600 sine 30 degree multiplied by 0.2. And you can see this force is creating clockwise clockwise couple. So we will take this as positive. Now this is the magnitude of the couple of the vertical component of the forces. Now plus magnitude of the horizontal component of the forces. So this force is in the line of the point O. So there will be no magnitude of this force, but the another force which you can see here, 600 cos 30. So this force will be generating a couple in this direction like this. So this will be 600 cos 30 degree multiplied by, now this is actually anti-clockwise, so we will be taking this as negative. So multiplied by 0.2. So if we calculate the solution, then we will be able to find out this as 43.9 Newton meter. And this will actually be positive. So which means the rotation of this gear will be like this, which is clockwise. So this gear will rotate because of these two forces. I'm just deleting. So because of these two forces, this gear will rotate in this direction, and the magnitude of the couple will be 43.9 Newton meter. Sorry, actually this will be negative. Yes, this will be one second. Yes, the value will be negative, which means the answer that I have solved here. So moment magnitude would be minus 43.9 Newton meter. So which means the gear will rotate anti-clockwise actually. So this will be rotating like this in this direction. I'm just deleting it. So this will be rotating like this, and the magnitude would be 43.9 Newton meter. So this is how we can find out the moment of couple of the system. So now we will discuss about the application of the moment in our structure. Well, in the structure analysis, this application of moment is a lot, and the major application is by using the principle of moment, we can determine the reactions in our structures. So like for example, this is a beam, and if this beam is resting on the two column, and if this beam is subjected to a vertical downward load, say W load, now because of this load, the reaction will develop on the both ends of the beam where beam is resting. So now how do we find out what will be the magnitude of the reaction on the left hand side and magnitude of the reaction on the right hand side? So how do we find out that? So in that case, the principle of moment will be very useful, and we can actually apply principle of moment to find out these reactions. So that is the major application of moment in our analysis. So as I said, the concept and application of moment can be found in many areas, but we will limit our use of moment in our structure analysis only, and specifically the determining the reactions. So specifically, we will use principle of moment for determining the reactions in the structures. But before calculating the reactions in the structure element, first of all, we will get introduced with some other concepts, because that will be very much required to understand the process of how we can calculate the reactions and to understand the analysis of structure. So we will continue this lecture in the next part. Thank you.